A web-based interface called the Scoreboard Analyzer was developed to help stakeholders make informed decisions across the manufacturing value chain. Users begin by securely logging into the Scoreboard Analyzer. The landing page features a dynamic world map on the right, visualizing the structure of the manufacturing network, including suppliers, warehouses, and production sites. Additionally, regions flagged by disruption indicators as potentially risky are highlighted, giving planners immediate awareness of vulnerable areas. On the left side of the interface, users begin the planning process by specifying the time horizon, which can span from a single day to several months. In this example, we'll set the planning horizon to begin next week. The user then defines the products to be manufactured within that window, including target quantities and deadlines for each. Here, we select Product 2 with a quantity of 200 to be delivered by the end of the planning horizon. We also add Product 3 with a smaller quantity of 10 and an earlier deadline. Finally, Product 5, which, like Product 2, is due at the end of the horizon. Next, the user adjusts the weights across 4 optimization criteria based on their specific planning priorities: cost-effectiveness, time efficiency, resilience to disruption, and sustainability. And finally, the user presses the Value Chain Optimization button to generate optimal value chain plans for the defined planning horizon. The system returns an overview of the optimal value chain plan on the right, along with alternative plans that reflect key trade-offs. These are presented to the user as clear summaries, highlighting differences in cost, timing, resilience, and sustainability. Again, users can view quickly actors' information by hovering on top of an actor on the accompanied map, and by clicking they can get additional information. The user can also choose any of the proposed plans to get detailed information about it. That includes the sequence of actions needed for its execution. The first table summarizes the materials to be ordered, showing proposed suppliers, quantities, and key attributes like price, resilience, sustainability, and the critical day, the latest date each order must be placed to ensure on-time production. Additional information can be accessed by clicking on any material or supplier listed. The second table details the production plan, including the required materials for each product, their source, either supplier or warehouse, and the scheduled production timeline. A virtual assistant developed by Helvia is integrated into the UI. We see the user interacting with the assistant to ask about the Maestro project. In a second interaction, the user asks for more detail about value chain optimization. The assistant's response highlights how the Maestro project includes sensing and predicting internal and external disruption indicators, and how the AI optimization engine, the core of the Scoreboard Analyzer, uses this input to generate actionable plans. The optimization is based on a multi-agent reinforcement learning framework, where key components of the value chain, including supplier, warehouse, and production, are modeled as intelligent agents. Each agent observes a partial view of the system, based on its role, and learns to take actions that balance local priorities with system-wide goals. To enable this, we use a transformer-based policy model that operates across time and agents. It learns patterns across sequences, helping each agent plan not just for the current step, but across a full planning horizon.